In this video, we are going to talk about the nature of metal oxides. And by nature, I mean whether they are acidic or basic in nature. Well, let me kill the suspense. Metal oxides, they are basic in nature. And by that I mean they behave as bases. Some of the metal oxides even get used as antacid, and they can be used to neutralize the buildup of excess acid in our stomach, just like bases. So let's see how metal oxides behave as bases. So you would recall that when an acid and a base react, they will neutralize each other's effect and finally form a salt and water. So if you are given with a chemical, some random chemical that is reacting with an acid and forming a salt and water, then you can be sure that this chemical has to be a base, because only a base can react with an acid to form salt and water. So now let's take an example of metal oxide and see how it reacts with an acid. So for starters, I'm going to take the acid HCl, and I'm going to react this with sodium oxide, Na2O. Sodium is a metal and this is a metal oxide. Now, can you imagine what are the products that will be formed in this case? Pause the video and think about this. So here there will be a double displacement reaction. The ions will exchange position. Sodium, it will get attracted now to chlorine and finally form sodium chloride, NaCl, which is a salt. And hydrogen will get attracted to oxygen and finally we'll get water, H2O. Let me balance this equation. Here we have 2 sodium, so 2 over here, 2 chlorine, so 2 over here, 2 hydrogen, 1 oxygen. Yes, this is balanced. So over here you can see that sodium oxide, which is a metal oxide, this is reacting with an acid to give me salt and water. So based on this previous reaction, I can say that metal oxide has to be a base because it's reacting with acid to give salt and water, right? Let's take one more example just to confirm things. This time I'm going to take calcium oxide. Calcium oxide. Calcium is also a metal and this is a metal oxide. And I'm going to react this with the acid HCl. Okay. So here also double displacement reaction will happen and the ions will exchange position. Calcium will get attracted to chlorine and we will get calcium chloride, CaCl2. And hydrogen will get attracted to oxygen and we will get H2O. Okay, let's quickly balance this equation. So here chlorine is 2. So let's put 2 over here. Now hydrogen is 2, 2. Oxygen, oxygen, calcium, calcium. So yes, this is a balanced chemical reaction. Here also, the metal oxide is reacting with an acid to give me a salt and water. And since we are getting salt and water, we can say that this metal oxide is a base. So we can say in general, metal oxides, they are basic in nature. They behave as bases. And this means that they can neutralize acid and form salt and water. So metal oxides are basic in nature. Is that it? Well, not really. There are some exceptions. This is chemistry. There are always exceptions. There are some metal oxides that not only behave as bases, but can also behave as acids. They can behave as acids and react with a base to also give salt and water. Let's look at their example. So first example is aluminium oxide. So let me first of all show you how it behaves as a base. Al2O3, aluminium oxide. And let's react this with HCl, hydrochloric acid. And in this case, we will get aluminium chloride, which is a salt, AlCl3, plus water will be formed, H2O. Let's balance this equation. So here we have 2 aluminium. So over here 2. Now I have 3 to the 6 chlorine. So 6 HCl. Now 6 hydrogen. So I'll write 3 over here. 3 to the 6. 3 oxygen, 3 oxygen. Yes, this is balanced. So over here, aluminium oxide is acting as a base because it is reacting with the acid HCl to give us salt and water. So it can only be a base. Now let's look at an example where aluminium oxide acts as an acid. So here I've taken aluminium oxide, Al2O3. This time I'm going to react this with a base, sodium hydroxide. And this time I will get a weird salt. I'm calling it weird because I always keep forgetting its formula. NaAlO2, sodium aluminate. And with this, water will be formed, H2O. Let's balance this equation. So here I have 2 aluminium. So I'll make this 2. Now 2 sodium. I've got 2 over here. Now this reaction is balanced. So over here you can see that aluminium oxide is reacting with a base to give me salt and water. And we know that if something reacts with a base to give salt and water, that can only be an acid. So in this example, aluminium oxide is acting as an acid, whereas in this example, aluminium oxide is acting as a base. So yes, aluminium oxide is an exception. It acts both as an acid and a base. We have one more example, that is zinc oxide. Zinc oxide also acts as both acid and base. Here in this example, zinc oxide is reacting with an acid to give us salt and water. Therefore, here it is acting as a base. Whereas in this example, zinc oxide is reacting with a base to give us salt and water. So here zinc oxide is acting as an acid. So this is also an exception. So far we have seen that metal oxides, they are generally basic in nature. Whereas there are some exceptions. Some metal oxides are called amphoteric, meaning they can act both as acid and base. And we saw the examples of them, aluminum oxide and zinc oxide. Okay, we started with the example of sodium oxide, Na2O. And we saw that this is basic in nature, meaning this will react with an acid to give us salt and water. And from our previous experiments, we have seen that sodium hydroxide, NaOH, this is a base. This will also react with an acid to give us salt and water. But you might be wondering, hey, what's the connection between sodium oxide and sodium hydroxide? So see, the connection is, if you mix sodium oxide in water, it is going to react, it is going to dissolve completely in water, and finally we'll get sodium hydroxide. So the key thing that I'm trying to tell you is that there are few metal oxides which are soluble in water. And then there are few metal oxides that are insoluble in water. Now, what do I mean by soluble and insoluble? So see, for example, if you take a spoon of sugar and you mix it in water, the sugar is going to completely dissolve in water and it will be completely mixed. Something similar happens with certain metal oxides, such as sodium oxide or potassium oxide, K2O, or calcium oxide, CaO. These are water soluble. These will mix in water and finally we will get hydroxides. Whereas there are certain other metal oxides that are insoluble in water. For example, magnesium oxide or aluminium oxide, Al2O3. These will not dissolve in water. Well, magnesium oxide, it does dissolve in water to a very little extent, okay? It's almost negligible. So for example, if you want to make sodium hydroxide, what you can do is burn sodium to get sodium's oxide. Just be very careful that this reaction is very explosive, okay? And then mix this sodium oxide in water and then you will get your sodium hydroxide, the base. Now let's summarize the video. In this video we saw what is the nature of metal oxides. And we also saw that there are some metal oxides that are both acidic and basic in nature. What do we call such oxides as? And can you give 2 examples of such oxides? We also saw that some metal oxides are soluble and some are insoluble. I hope you can remember one example at least of both of these. Now, if you can answer these questions, well and good. And if you could not, then don't worry. You can go back and watch the video again.